Welcome to this course on machine learning using Python programming. In the previous lecture, we have seen some attribute selection measures for decision tree in case of classification, and we have seen the concept of entropy that will be used in today's lecture, because now we will see two more attribute selection measures in today's class, that is information gain and Gini index. So, till now we have covered introduction to decision tree for classification, and then attribute selection measures that we have seen reduction in variance, how it is used for attribute selection measure, what is the meaning of attribute selection measure, and so on, and then what is entropy. So, we will see now information gain and Gini index, these two most popular attribute selection measures in this today's lecture. In the next lecture, we will see how we deal with continuous attributes, and there is another attribute selection measure, that is chi-square measure. So, how chi-square is used for splitting the node, and then what is the pruning and why it is required. So, all these together will form the decision tree for classification. So, let us see what is information gain. So, information gain measures how well a given attribute separates the training example according to their target classification. It means when we are using any attribute, how well it is dividing the data set into two or more nodes, such that each node is more pure node. So, how it is done? In this case, we can say this measure is used to select among the best among the different independent variable, the best independent variable, so that when we will use that independent variable, we may get better nodes, better subnodes, or more pure nodes. So, here information gain. So, first of all, gain. So, gain is a measure of reduction of uncertainty. So, whatever node we are having, and if we are trying to split that node, so uncertainty, if we are having some uncertainty in that node, means we are not sure whether when we will randomly select any instance to which class it will belong. If we do not know, it means there is uncertainty, and it is better to split that node in other subnodes, such that when we will select any instance from one of these subnodes, in that case there is more, we will be more certain to say that what will be the class of that instance. So, gain will tell us what is the reduction of uncertainty when we will split any node using a particular attribute. So, what is information gain? We can say it is a measure of changes in entropy after the segmentation of the data set based on a attribute. So, there is a node, we are splitting it using an attribute, and so we will check what is the change in entropy, what was the previous entropy of the original node, and when we split it in two or more than two nodes, now what is the entropy. So, what is difference between these two entropies. So, it calculates how much information a feature provides us about a class. So, when we are using a particular feature for splitting, then after splitting using that feature, how much information it has provided for the class of those instances in the subnodes. So, that is why it is called as information gain, and a decision tree always tries to maximize the value of information gain, means when there are more than one independent variables, and we will always select the attribute variable that will give you the highest information gain. So, it means when we will, suppose there are 3 independent variables and we will split your data set using all these 3 one by one from by all these 3 variables, then we will calculate information gain for all these attributes, and then finally we will select that attribute for which information gain is maximum, because it is reducing the uncertainty. It is after splitting using that attribute, you are more certain to say when you will select any instance from the subnode randomly, then more certainly you can say that the class of this instance may be this particular class. So, how it is defined? Gain of SA. So, this gain is defined for a node, that is node, that node is denoted as S, and then A. So, A is nothing but the attribute that is used to split that node S. So, we are now trying to find out gain SA, means how much gain we are getting using attribute A to split. So, how much gain we are getting after splitting by attribute A, and what we are splitting is splitting the node, that is S. So, how this gain is defined? This gain is defined by entropy of S minus summation over all the values of attributes, means for each attribute V, we will calculate SV mod of SV upon mod of S, entropy of SV, means when we will select, suppose attribute A is age. In that case, if there are 3 values in A and these values are young age, middle age and old age. So, we will calculate number of instances corresponding to old young age upon total number of instances into entropy of that young age node. So, similarly we will add one, we will subtract one term corresponding to number of instances in the middle age upon total number of instances into entropy of that middle age. So, node corresponding to middle age and so on. So, in this way we will calculate the gain gain that we are getting if we will split node S using node A, attribute A. So, basically the idea is when we will split node with some attribute A, suppose we are getting 3 subnodes. So, we will calculate entropy of these three subnodes, and then definitely we will take weighted average of this, and then we will try to find out what is the information gain in terms of entropy of the original node minus weightage average of entropy of these subnodes. So, in this way we will get how much gain we are getting after splitting the node using a particular attribute or using different attributes, and then we will select that attribute for which this gain is maximum. So, as we have seen different variations are there for decision tree like ID3 and cart, assistant. So these they are different variations of decision tree, and ID3 is the algorithm in which attribute selection measure is information gain. So information gain is the attribute selection measure that is implemented in ID3 algorithm, that is one of the decision tree algorithm. So let us see information gain by an example. Suppose you are having a node in which there are 29 positive instances and 35 negative instances. So, there are suppose two attributes or two independent variables, one is A1, another is A2. Then the question is whether to, at this particular step, we should split it by A1 or A2. So, suppose when we will split is using A1, so and it is both of these two are categorical variables and they are supposed to true and false values are there. It is not necessary, it may be, it may contain other values also. Suppose it is a categorical variable, but it may have red, green and blue. So, in that case this node will be divided in 3 sub nodes. Red, one will be corresponding to red, another will be corresponding to green, and then the next one. So, based on that we will divide the node, but here we are considering that these attributes are categorical attributes. So, in this case when we will split this node using A1 also, using A2 also, and suppose after splitting through A1 you are getting a sub node where 21 is the positive instances and 5 are negative instances. So, definitely all these instances will have true value in A1 attribute, and in the same way in the another node there is 8 positive instances and 30 negative instances. So, all these instances will have false value in the attribute corresponding to A1. In the same way, when we used A2 for splitting this node, we got suppose these two sub nodes. Now, how we will decide whether we should split using A1 or A2 at this step? Let us see how information gain can help us in deciding which attribute we should use here. So, what we will do? We will first compute entropy of this node, then entropy of this node, and then we will calculate weighted entropy of this, and we will calculate entropy of this also. Then we will subtract weighted entropy of this from entropy of this node. So, that will be the information gain. In the same way, we will calculate entropy of this node, then entropy of this split, and then we will subtract this weighted entropy of these two nodes, that is the entropy of this split from entropy of this node, and then we will check whether the information gain of A1 is greater than A2 or not. If it is greater than A2, then we will use attribute A1 as the information gain, as for the split at this step, or we will use it, otherwise we will use A2 for split at this step. So, this is the entropy for this node is calculated. So, 29 positive instances are there, 35 negative instances are there, and we have seen the formula for entropy of a node was probability of positive instance, then log of positive instance minus. So, if we will take minus sign already, then plus probability of negative instances, log of negative instances. So, base is 2, log base 2. So, when we will calculate it, so we will get 0.99. So, 0.99 is the entropy of A1 or sorry, this node, root node. So, here this is the root node. So, entropy of root node we have calculated. Now, we will need to calculate entropy of this. How we will get? Entropy of this will be, we will calculate here the entropy, the probability of positive instance. So, that is 21 upon 26, because total 26 instances are there. So, 21 upon 26. So, then log of 21 upon 26 plus 5 upon 26. So, that is probability of negative instances. So, 5 upon 26 into log of 5 upon 26 and then minus of that. So, you see, so here entropy of this node is directly written here, value is directly written. So, in the same way we have calculated entropy of this node. So, entropy of this is also written. Then we calculated gain of SA1. So, that is nothing but this entropy of S minus weighted average of entropy of these two nodes. So, you see here we are having 26 instances. So, 26 upon total number of instances in this node, that is 64. So, 20 upon 64 into entropy of this node, left node, minus entropy. So, this is 38. So, 38 upon number of instances in this node, that is 62. So, 38 upon 62 into entropy of this node. So, 38 upon 64 into entropy of this node. So, in this way we will get gain for attribute A1. In the same way we can calculate gain for attribute A2, and then we will select that particular attribute for which gain is maximum. So, here two attributes are there. So, out of these two attributes, gain for A1 is maximum. So, at this step we will select A1 for splitting this node. So, this is the information gain. So, you can see here the entropy of this was whatever the entropy was of that node, of this node was, and then what is the idea? We are subtracting from that entropy of this split. So, and then we are saying the amount, this when we are reducing the weighted entropy from this, and that value is large, that attribute we will select. So, here you can say that you are getting more, you are more confident in saying that positive instances, you will select one instance from here, then more confidently you can say that this is the positive instance. Here again, because 21 instances are positive and only 5 instances are negative. In the same way here also 30 out of 38 instances, 30 instances are negative. So, you are more confident that the instance may be negative. While in this case you see 18 instances are positive and 33 instances are negative. So, when you will select one instance from these, you may be, we are not that much confident that it is positive or negative, because this difference is not much. So, your information gain is giving you the correct result. This is another example where you see. So, I already told these examples and these decision tree slides I have taken from that website that I have shown in the previous lecture. So, this example is also taken from there. So, you see this is a data set of some persons where name, age, then apple pie, potato salad or sushi, and then there is a attribute Midwest. So, based on these attributes, we are trying to learn whether the person belongs to Midwest or not. So, based on his choices for apple pie or potato salad or sushi, whether the person belongs to Midwest or not. So, 1 and 0 values are in this column. So, here also 0 1. So, it means the person likes apple pie or do not like apple pie. So, if it is 0, so the person does not like apple pie, here 1. So, person likes potato salad and so on. So, our goal is, so it was, you can assume this is this was a quiz, and in this quiz, from this quiz your goal is you need to guess if the quiz taker is from one of the this state of America, that is Midwest. So, how we will do this? We will need to means this is the whole data set, and if we are doing decision tree, then we will need to find out which attribute, and suppose there are 3 possibilities or basically 4 possibilities. So, since we are having, if we are considering these 4 as independent variables, then age, apple pie, potato salad and sushi, these are the 4 attributes that we can use for splitting the data set. But we will first take these 3 attributes, and based on that we are trying to split the data set. Now, the question is whether we should means initially we should split it using apple pie or potato salad or sushi. So, we will see how we will apply information gain here to find out which attribute we should use to split first. So, first of all we will calculate entropy of this data set or entropy of the node corresponding to this data set. So, here you see in the Midwest there are 2 values 1 and 0. So, we will calculate means and the formula for entropy is minus summation of I is equal to 1 to C probability of xi log probability of xi. So, what is this C? In case of C, in this case C is 2, 0 and 1. So, means there are 2 classes. So, first of all we will find out what is the probability that instance is belonging to class 1 and then log of that probability, then probability of the instance belonging to class 0 and then that probability. So, probability of class 1, how we will calculate? There are 10 ones and these there are total 15 instances. Out of these 15 instances 10 are 1. So, this probability of 1 is 10 by 15. Probability of 0, so there are only 5 instances that are corresponding to 0. So, probability of 0 is probability 5 upon 15. Then we will calculate this 10 upon 15 into log base 2 10 upon 15. Similarly, 5 upon 15 into log base 2 5 upon 15, and then we will sum these 2 numbers, and finally, in front of that negative is there. So, we will take minus of this. So, in this way we will get entropy of the whole data set or entropy of this node. Then what we will do? Now, our goal is to find best feature or best predictor to split on when building a decision tree. Means at this step we will need to find out which feature we should use for splitting. So, how many features are there? So, we are considering apple pie, potato salad and sushi. So, let us start from the potato salad. So, when we will split it using potato salad, So, in this you will have all the instances where potato salad is 1, and here all the instances where potato salad is 0. So, here we can calculate again information gain. So, we have already seen the entropy of the previous the whole data set we have calculated. Now, we can calculate entropy of the left subtree, calculate entropy of the right subtree, and then weighted entropy, and then we will so here we are getting the information gain. So, that is entropy of the the data set minus weighted entropy of these two sub nodes. So, this process we will repeat for every column means for apple pie and sushi also. So, and then we will find out for which out of these 3 information gain is maximum, and we will use that particular attribute for splitting at this step. Now, we will see another splitting rule, that is Gini index. It is also called as Gini impurity. So, this in CART algorithm we use Gini index to create binary splits. In ID3 we use information gain, and in CART we use Gini index. So, Gini index is also very popular attribute selection measure, and what is Gini index, how it is used for splitting purpose. So, it is the concept is similar, but we will see what is difference and what is how it is used. So, first of all, here Gini is defined, and we can calculate Gini for each and every node, and how it is defined, it is 1 minus summation over all the classes probability of square of probability of that class. So, in any node, if we are having suppose 2 classes, so how we will calculate Gini, 1 minus probability of getting one class, square of that probability, and in the same way square of square of probability of getting another class, and we will take sum of these two and we will subtract it from 1, we will get the Gini of that node. And what is Gini impurity? So, Gini impurity is defined as 1 minus Gini, and then we can, after calculating Gini of all the nodes, we will calculate Gini of the split as we have done in information gain. So, how we will get Gini of split? So, that is weighted average of Gini of all the nodes. So, let us see by example. So, before that let us see with an example what is Gini, how we will calculate Gini, and what is the meaning of that. So, as we discussed what is Gini, Gini is square of probabilities of different classes. So, means if you are having one node, and in that node, let us first discuss this, you are having a node, and in that node different instances of different classes are there. So, you can see here 2 instances of a particular class, purple class suppose, 2 instances of green class, and rest of the instances of red class. So, how we can calculate Gini of this node? So, Gini of this node will be probability of getting green class, probability of getting purple class, probability of getting red class, and what we will do, we will calculate square of all these 3 probabilities, we will take sum of that, it will be Gini of this node. Here what is the probability? So, there is probability of getting red class is 1, probability of getting green class is 0, probability of getting purple class is also 0. So, in this case when we will take sum of that, so square of probability of getting red class is 1 square, that is 1 only, and that is why Gini of this will be 1. So, after calculating Gini, we can calculate Gini impurity or Gini index. So, that is 1 minus Gini. So, here we can say that Gini ranges from 0 to 1, as it is a probability, because we are taking sum of these probabilities. So, Gini ranges from 0 to 1, and higher this value, the more pure node is that, as we have seen here. So, here probability of red is 1 and probability of purple and green is 0. So, here Gini is 1. So, if it is 1, it means this is more pure node, and in other cases if that node is impure node, then definitely these probabilities will be less probabilities and we will take sum of them. So, it will be less than 1, these values will be less than 1 or close to 0. So, if this Gini value is close to 0, it means this is more impure node, and if it is close to 1, it is more pure node. So, this is the Gini impurity, since we are defining as 1 minus Gini. So, Gini impurity measures the degree or probability of particular variable being wrongly classified when it is randomly chosen. So, you are selecting any instance from the node, and it is wrongly, it will be wrongly classified. So, Gini impurity measures this probability. What is the probability that a particular variable being wrongly classified when it is randomly taken? So, degree of Gini index, where it again varies from 0 and 1, where we can say that if it is 0, so it denotes all elements belongs to a certain class, because it means Gini is 1 and Gini was when 1, it was the most pure node. If it is 1, it means elements are randomly distributed across various classes, because in that case Gini was 0. So, in the same way when it is 0.5, so it denotes equally distributed elements into some classes. So, we have seen what is Gini impurity. So, it is defined as 1 minus Gini, and Gini denotes purity, and hence Gini impurity denotes impurity of the node. So, using Gini impurity or Gini index, we are trying to find out which node is more impure node. So, lower the Gini impurity, we can safely infer the purity will be more, and hence higher chances of homogeneity of the node. So, we will try to find out that attribute for which Gini impurity is less. So, we will calculate for all the independent variables, we will use those independent variables for splitting, and after splitting we will calculate Gini impurity for all these attributes, and we will finally select that attribute for which Gini impurity is minimum. So, Gini works only in those scenarios where we have categorical targets. So, it does not work for continuous targets, and that is why we have seen in case of continuous targets we use reduction in variance rather than these Gini or other attribute selection measures. And so, we can say that in case of regression problems we should not use Gini, we can't use Gini. And what are the steps to calculate Gini impurity? So, it is same as information gain or reduction in variance. First of all, we will calculate Gini impurity for the subnodes, and then we will calculate Gini impurity of the split, and Gini impurity of the split will be calculated by taking weighted average of Gini impurity of all the subnodes, and in this way you will get the Gini impurity of that split. So, if there are 3 attributes, we will calculate Gini impurity of all these 3 splits corresponding to these 3 attributes, and then finally we will select that attributes for which Gini impurity is minimum. So, this is same example. So, using average, using class performance in class, if we split this node in these 2 subnodes. So, in that case we can find out Gini impurity for this split. So, first of all we will need to calculate Gini for this subnode, Gini for this subnode, or using that Gini we will calculate Gini impurity for this subnode, and then Gini impurity for this subnode, then weighted Gini impurity of these 2 subnode will give us the Gini impurity for this split. In the same way we can calculate Gini impurity for another attribute, that was the class attribute, in which we were having two values, class 9th and class 10th, and then we can compare for which attribute we are having less Gini impurity. So, in this example we have finally we will get less Gini impurity for attribute class, and that is why here at this step we should using the Gini impurity, it is suggesting that we should use class variable as a variable for splitting that node. Algorithm, these two algorithms are most popular variants of decision tree, and in the next class we will see other remaining topics of decision tree, other remaining attribute selection measures, and then we will see what is pruning and all. So, I am stopping here. Thank you.